Welcome, everyone, to the latest podcast edition of Reimagine Mobility. I'm here with Amy Nelson from AVL Fuel Cell Canada. Amy, thank you for joining me today. I appreciate it.
Thank you so much for having me.
Yes, thank you very much. I heard you've been in the fuel cell industry for 20 years now.
At least.
At least 20 years. See, I even got the wrong information that they're giving me. So at least 20 years. I guess right to start out with, I'm wondering why fuel cells? Well, what is so exciting about fuel cells?
I think when I was doing a master's degree and I heard about Ballard for the first time in the late 90s. And I think at that time, climate was a topic, not like it is now, but it was. Mm-hmm. And I was very interested in the kind of work that would contribute to improving our world, the way we use energy, the way we pollute. And so when I heard about Ballard, I just found that very exciting. And I had been doing a degree that touched on electrochemistry, and I thought, wow, that is really what I want to do. I was a chemical engineer by training, and the job opportunities in chemical engineering tend to really focus on oil and gas. And I wasn't sure that was an industry that I wanted to contribute to. So at that time, I just got really excited about fuel cells. And I still am. I still think they offer a wonderful opportunity to decarbonize a lot of various areas of industry and transportation.
Mm-hmm, mm-hmm. With fuel cells, again, we talked about a fuel cell and hydrogen. We're certainly focusing on a completely, let's say, green economy, right? No emissions, greenhouse gases, et cetera. From an efficiency point of view, because you're talking about, right, and how long you've already worked in this space, and we've certainly come a long way. Maybe shine a little light on how far have we come from an energy density point of view, from a stack where you were, again, 20 or maybe even 30 years when you first started to today. And then tell us also how much further you think we can go, right?
Yeah, from a power density point of view, like how much power you can get out of a certain size of package, we've really come a long way. I think we've probably quadrupled power density since we started within the industry. And currently in my job at our company, we're working on something that makes a 50% improvement on that. Again, I think there's still quite a bit of improvement that we can make in the next 5 to 10 years on power density. And the great thing about working on any one particular metric or characteristic of a fuel cell is that often it can be used in many ways. If we get to a point in power density where, it's really small enough to suit any kind of application, we can also use those improvements to get better efficiency, to operate better, to get longer lifetime. Mm-hmm. So it's still really exciting work.
Okay. When we talk about fuel cells, you always have more or less the opposite camp and says fuel cell and hydrogen doesn't really make sense. We need to focus on batteries. I always sort of maintain, I think they have a place each of their own, right? They both belong. From your point of view, and maybe specifically from a chemist's point of view, you probably very well understand the challenges on the actual battery cell, right? And what we're working on now, pushing heavily into solid state, for example. But correspondingly, what is specifically from a chemist's point of view that we're looking at on the fuel cell stack?
On the fuel cell stack, From the electrochemistry point of view, we're always looking for improved performance. That ties into what I was saying previously with improved performance of the chemical reactions that are happening. You can always either reduce the size of the stack for the same power or maybe operate at a different point that allows you to be more efficient. So those performance improvements are always beneficial. We're also looking, I think, quite similarly to batteries. We're always looking for materials that are more durable. That's a very important aspect of our work, is making everything last longer. And last longer in different kinds of applications under different operating conditions. And the third thing is we're also looking for not only durability of the stack itself, but maybe materials that will enable the system to be better or cheaper or more durable itself. So the fuel cell usually has a bunch of auxiliary components around it. So you have to feed fuel, you have to put air into the fuel cell, you need coolant, and you need to condition the air in particular. So anything that we can do in the stack to make the requirements on the system easier is also something that we're often looking at.
Okay. When we talk about electric vehicles and batteries, right, the big buzzword is obviously be as efficient as you can from the cell all the way to the battery and then the complete vehicle. So from the component to the subsystem to the complete system. Is that the same in fuel cell stack, or is there something to be said? It's not always about the highest efficiency, maybe because it's also durability and there's a trade-off, there's cost. We clearly have that too, I think, in batteries, but it's not very often or really not at all talked about. But tell me a little bit how it is with fuel cell stacks.
Yeah, there's always a trade-off for sure. And it depends on the customer and the application, what they really need. A battery is very efficient, and a fuel cell is much less efficient compared to a battery. And to what you said before, there's a place for both. For sure, if a battery meets your needs, that's probably what you should do. But there's also a lot of applications where it's a really difficult use case for batteries, and fuel cells make a lot of sense. And yeah, sometimes efficiency isn't really the most important criteria. Sometimes convenience is, ease of use. Often for commercial operators, it's total cost of operation, and efficiency plays a part in that, but it's not the full story in that. So uptime of a commercial vehicle, the amount of shifts that you can run, which speaks to refilling time or recharging time in the case of a battery. There's a lot of factors at play here. Sometimes a fuel cell really makes a lot of sense, even though it may be less efficient. There may be other costs or other areas where it outperforms batteries.
Interesting. With your, again, 20 plus years of experience, tell me a little bit about what has changed, right? I mean, clearly I would assume, again, not knowing, but I would assume 20 years ago you had a whole lot less, I would say, virtual tools or simulation tools to develop a fuel cell stack or the individual components within it. You already alluded, you quadrupled or tripled the energy efficiency. But what has changed, both from the environment that you worked in to today, with the tools that you're using, maybe the approach, anything and everything? Shed a little bit of light on that.
Yeah, I think everything you mentioned, everything has changed in the industry. Absolutely everything from, like you said, the working environment. When I started, it was very much, I don't know, it felt like, a startup, like a garage operation. Obviously, we weren't in a garage in Ballard, but everybody kind of wore multiple hats. And if you needed a tool, you had to develop it, that kind of thing. And that was a lot of fun too, but it's really nice now. A company like AVL and many of the other people in the industry have developed fully fledged commercial tools to help in the development of fuel cells. So when I need CFD or FEA or something advanced like that, there's a tool that will do it for me. like the technology itself has developed. So catalyst technology, membrane technology, both in performance and durability, have come miles and miles. It's amazing how much performance we get out of a stack these days and how long it will last under a variety of conditions. Also, the supply chain for those materials has really evolved. We used to kind of make our own. There was nowhere to buy the stuff that you needed. Now you have a choice among suppliers for membrane, for catalyst, for an integrated membrane and catalyst assembly, for plates, plate materials. You really have a lot more choice. There's a lot of entrance into the market, into the supply chain. It's really astonishing. Another thing that's changed is the level of interest in fuel cells. Back in the day when I worked, we were more pushing, trying to find customers. Now customers come to us all the time. There's a lot of interest in fuel cells. There's a lot more fuel cell developers in the market. In Vancouver alone, instead of just Ballard, now there's 5 or 6 companies operating successfully. So the whole environment is different. It's a completely different world.
Yeah. What would you then say with that? I mean, again, you're saying customers are now coming instead of us having to go out or you having to go out and say, come on, give fuel cell a chance, right? Give fuel cells, give the hydrogen industry a chance for the mobility space as a fuel, right? It sounds like, based on what you're saying, what I've also heard from others is the money is now there. People are coming and actually willing to invest in it, asking us at AVL, hey, develop me something. And it's not a small little prototype or a feasibility study. We're talking the entire fuel cell stack and ultimately then the power plant, right? Work on some programs right now on a global basis. Is it then now is the time we are ready now to really start deploying these things at much larger scale that maybe 15 years ago, 10 years ago, you could see, but you knew it's not quite the time yet?
Yeah, this time feels really different. I've lived through a couple of, for lack of a better word, hype cycles around hydrogen. Maybe this is the 4th cycle I've seen, and this one really does feel different. There is a lot of different customers, a lot of different areas of industry and transportation that are looking at fuel cells. A lot of forward-thinking companies that are seeing, okay, we really do need to make a change now in how we operate and what kinds of energy sources we're using. Another big change, I think, that's driven a lot of the industry here in Vancouver, at least, is a very big change in China over the last, maybe starting 10 years ago, that began to be very noticeable 5 years ago, creating a lot of demand for fuel cells, for fuel cell technology, for fuel cell know-how, for materials and parts. It for many different reasons, it does feel different now. There's a lot more government funding, government interest alongside the interest in industry, and those are really playing well together and creating a very interesting industry to work in right now.
You see similar activities? I mean, we're talking here fuel cell stack that takes hydrogen as an input to generate electricity, power a battery, power an e-motor for, let's say, a heavy-duty truck application. Do you see similar type of level of activities in the electrolysis side? I mean, we need to kind of have both, right? We need the hydrogen in order so we can run a fuel cell stack, but do you see similar advancements in the technology on that side?
I think so. And to be honest, electrolysis isn't my specialty, but I think that market is even bigger right now and kind of exploding even more than fuel cells. It's been looking very interesting to me. I'd like to learn more about it. But the whole idea of decarbonization or of using hydrogen really hinges on making hydrogen in a green way. And so wind, solar, hydro to some extent. So there's a lot of interest in how to store renewable energy. It's not convenient to put all that electricity into a battery. It's way more convenient to put it into some kind of gas or liquid. Hydrogen is a great candidate. You can store it, you can ship it. And so, yeah, I get the feeling everybody's trying to buy an electrolyzer. And there's a lot of movement in that technology as well. That is very similar to technology to a fuel cell, and is advancing rapidly as well in areas of efficiency, durability. I think it's going to be very interesting times in electrolyzer sales in the next few years.
Right. Maybe final question. Again, in an industry for a long time, you seem still very excited. I can see the enthusiasm you still have. It's great to see. I mean, this is awesome. So let's say another 10 years easily, right, Amy? And what do you look forward to over the next 10 years in when it comes to fuel cell stack technologies? What do you see changing? Not necessarily power density, but just in general. What from a purely technology standpoint, from purely what you're doing on a daily basis, what do you see happening over the next 10 years?
That's a really good question. On a technology basis, I just see, and something that I really look forward to is seeing units out in the field and getting like real world durability, verification, assessment, getting data back on how things perform in real world conditions. In the fuel cell arena, we have hours and hours and years of lab data. And sometimes that's not really how things get used. So I'm really interested to get more and more products out into the field. Really making a dent in durability. And one thing I'm really interested in, we talked about simulation a little bit. I am very interested in simulation. And the tricky bit there is, you can simulate durability. You can think about how to mathematically represent that and make some nice models, and they look good. And you don't really know if they are good until you get some data back from field operations. So I'm really looking forward to improving our simulation capability in that regard, and to understanding how things fail or don't fail. Often as engineers, we worry a little bit too much about how things will fail. And then it turns out, they do just fine out in the wild.
I have the same problem when I go into something that I'm looking at. It's like, I don't know, has an FMEA be done on this thing, or is this safe? Sometimes us engineers sometimes are our own worst enemies, right? When it comes to this stuff, because we always see a failure instead of the joy of what we developed, right?
Yeah, and we work a lot with use cases in the lab where we're trying to make things fail so that we can engineer them better. And so all we see is failure. And sometimes I look at, I have a Nexo, a Hyundai fuel cell car that I drive on a daily basis. And, sometimes I'm getting into it thinking, oh my gosh, it's, how is this still working? I've been driving it for 3 years. It should have failed by now, because that's what I do in the lab is I make stuff fail. But it's remarkably robust. Like nothing goes wrong with it. I get into it. It's my daily driver. It always starts. It always runs.
Nice.
It's fantastic. I mean, it's technology that's ready for use. So I'm really excited to watch the next 5 years and see the technology being used.
Very good. Well, thank you, Amy, for your time today. And thank you, everybody else, for tuning in.
Thank you so much. It was a pleasure to chat with you.
Thank you, Amy.
Thanks for listening to Reimagine Mobility Podcast. If you like this episode, please subscribe and tell a friend.